Hey everyone, this is Josh, and in this video, we're going to learn how to debug in the Plutus framework in Cardano. This has been a long video in the making with some frustration of trying to figure out how things work. So I'd like to share with you all some of the process that it took for me to get this far. And just like in every video, we're going to start with a mini project. In this project, we're going to have users locking up their ADA, and then we'll have users redeem their ADA. The twist is that there'll be multiple users, so we'll learn how to pick one person to redeem our ADA from. And I'll show you what I did to debug the code while I was developing it to see how it works. And to keep things simple, we're going to have a null datum and redeemer, and we're not going to pass any params in. And we're just going to solely focus on debugging. So without any delay, let's get started. All right, so we're back on the Plutus playground. We're going to go to the starter template, and we're just going to update this template to match our code. And so, like I mentioned, we're not going to send anything to the validator script. That's not the purpose. We're just going to learn how to debug and look up code. So we don't need to even define our datum redeemer over here. And then for the type that we pass in our validator script, we'll just set them to the null type. And then for the end result, we're just going to return true. We don't really care about what we're passing in. Now, I will say that one thing that is very unfortunate that I realized is that you actually cannot debug your code on the on-chain code. Instead, the only way to actually get any information is that you need to take advantage of Plutus's conditional checking logic that will then print something onto the code. It's not ideal, and I would love to be able to actually debug it, but unfortunately, it is what it is right now. So continuing forward, let's continue removing the mention of the redeemer datum. All right, that should be all. So after we've handled our on-chain code that we're passing in, let's update our endpoint to not include anything. So we can see our endpoints defined in our schema. And then as you see in the implementation of endpoints, we need to remove the params that we consume. In this case, just get a void type. The datum over here is empty, so we'll just pass in void. And so on and so forth. All right, so now we're in a clean state. We have just removed any mention of any datum or our param types. The next step after we've done all this is we need to implement our off-chain code. This is the code that submits the transaction to our on-chain code. The simplest case right now is the publish endpoint. We're not going to do anything fancy. It'll be very similar to what we've done in the past before. Instead of passing the locked funds that the user might have specified, we're just going to hard code a specific value. Of course, because we call the ADA module, we need to actually import it. And we scroll up, you can see there's no mention of ADA. So we need to import the module. All right, so we import the ADA module, the ledger.ada module, with and we're going to qualify it as the ADA keyword. And so this is how we reference ledger.ada. We call ADA dot whatever value we want. In this case, it's just ADA directly. All right, so that's all we need to do for the publish endpoint. Very straightforward. The more interesting part now is the redeem endpoint. So at the redeem endpoint, let's take a step back. What does every endpoint do? Well, every endpoint, we need to submit a constraint to the on-chain code to do something. In this case, our on-chain code will always return true, so we'll always take the ADA. And we'll probably need to do some validation, but we won't get into that in this video. The important part is that in our redeem endpoint, we need to define a transaction to send across the network. And in this project, a list of users that has offered up their ADA to be redeemed. And as a redeemer, we only want to redeem one of those users. So the first thing we need to do is we need to get a list of all of our UTXOs, specifically the people that publish their ADA for other people to redeem. The first thing is we're getting all of our unspent transaction outputs by calling the funds at address greater than equal function. And what this does is that it takes in the contract address, which is already provided to us up here. the address to our validator script. And then we give it a condition that we want all UTXOs that has a locked-up value of 1 Lovelace or more. And this arrow function is just a way for us to asynchronously wait for the result inside our do function. So now that we have one call, we don't need to keep the other one. And now we can actually use our UTXOs. So now before we get into that whole jumble mess, I want to explore what exactly we got from the UTXO. And this was part of the debugging and development process because I really didn't know what the UTXO object was. So how do we get that information? Well, I just printed it. So Haskell has a helpful function called loginfo, which would print a string onto the console. So what we're doing is we're calling the show function on our UTXO. Show basically just converts any object into a string format. Of course, we need to import this. Now specifically, what we're importing is not actually the show function from the default Haskell library. We're actually importing the show function of the prelude module that is included inside Plutus. Now with that, we should be able to compile and take a first peek at what our UTXO looks like. Yes. So one mistake was I removed the unspent output, but we're still using it, the variable. So for now, let's just comment out the code. Because all we're curious about is what the UTXO is. All right, so we compiled. So let's quickly go to simulator. So wall 1 we'll just publish, and I'll give up like 1,000,000 Lovelaces. We wait. Wall 2 will redeem, and then we wait again so we get the results. And then we evaluate. Now as you can see, wall 1 did give up the 1,000,000 Lovelace, but wall 2 hasn't redeemed anything, and that's because we haven't sent any transaction. We just printed. And if we scroll all the way down, and we go look for our contract log, which is over here, we can see that we're printing out the object type. So we get a string form, and of our string, we have a from list, and then we get a list of mappings of tx_out_ref and script chain index transaction out. Now, I actually copy pasted this into my Visual Studio Code and formatted it, so that's why I know it's a key value. Okay, so before we talk a bit more, what's interesting to me is that there's a from list module, and that confused me, but this is actually just a way to say that this whole thing is a map object. Very confusing. It took a lot of searching up on Stack Overflow to understand the syntax, but I believe that's all this really is. This whole list is being converted into a map. Now, if we were curious about this unspent transaction output and what the format looks like I was, you could actually do some more investigation and learn how the code works by looking at the source code. So we know that the UTXO we got in the original code is from this funds@address greater than or equal to function. So what you could do is we just go to Google, search up that function, and then you go into okay, fine. So this is another problem that I had. I guess you could look for this function in GitHub, but for the sake of this video, I just go to the cache value and I go look at this function. And then we see that the funds@address greater than or equal to returns a contract which on success gives us a UTXO map. So then that's what the arrow function does in the code that we saw. It takes the map out of our contract. So now we know UTXO map. If we look up UTXO map, we see that it is a type of map and includes a key value pair of transaction outref and transaction out. Now, I will say one thing is that this documentation is slightly deprecated. We actually don't have these specific two types. It's actually pretty similar. If we go back down, we'll see that we still have the transaction outref, but the other variable is actually the script chain index transaction out. which as you can see right here, it's not that, it's something else. So that was part of the frustration I had in debugging and trying to get this code to work, because the documentation wasn't even technically correct. It took a while to figure that one out. But nonetheless, if we go back and look at some of the code, we can see that there's some helpful information inside this transaction out, and some of it includes the datum information that we have right here. In our case, we didn't include any datum information, but if we did, you can imagine that this is how we would begin to filter all of our UTXOs. We would search through our UTXOs in our list one by one to look for something that has datum or a script address that matches our requirement. All right, so that's neat. And that's basically how I started debugging the code and trying to figure out how to do what I want to do. So we know our UTXO is a map of key value pairs of all of the transactions that the users have submitted to the network. So we need to extract that information out first. Now, if we go back to our code, we know that every endpoint needs to submit a transaction to the on-chain code. In our case, as you recall, this submit transaction constraint spending would actually take in all of our unspent outputs and then submit it. Unfortunately, in our case, we don't actually want one user to redeem all of the published endpoints. We just want to redeem one of them. And from looking at other examples from the Plutus Pioneer program, I found out that there's another function we can use to achieve this. And that is this function called submit transaction constraints with. Submit transaction constraints with just allows you to actually specify what constraints that you want to follow to submit a transaction, along with the actual usual transaction that you send. So this is actually UTXO, this is constraints. So to clarify, our transaction we provide is basically a script that contains the redeemer value if we had any to give, and the UTXO that we want to provide. And our constraints is basically all the actions we can apply to our UTXO that we submit. In this case, it's pretty straightforward. We just want to submit one transaction. Let's first start off by creating our transaction that we're submitting. So the first thing is, instead of using the must pay to the script function, there's another one we can use called must spend script output, which once again, I also took from the Plutus Pioneer program. So for this function, we need to include a UTXO, which I'll just call a UTXO over here. We don't have anything yet. Oh wow, embarrassing. This is actually, I've been putting the code in the wrong side. So let me revert this. And move this code back down here. All right, we'll do this again. So continue off. We need to provide the UTXO, which we haven't redeemed yet. And we also need to provide the redeemer value. So what I found out is that you actually can't just provide null value. You actually need to give an empty generic redeemer type. So all this function does is it creates a null Plutus TX type, which then we pass to our redeemer object, which is just a generic object, and we just create a generic redeemer that doesn't get used or do anything. The next thing we need to do is we need to get our UTXO that we want to submit. In this case, it's slightly easier because we don't care about any specific condition. We just need to grab one UTXO from our list of UTXOs. And we're going to ignore any edge cases like what happens if the UTXO is empty. We're just going to assume something exists. So I dug around and I found out the way to extract a value from our map is we need to first convert our map into a list. And we can just quickly set that inside a variable. So quite a few things are happening here. First thing is we're calling the map.toList, map being the built-in Haskell data structure, and toList converts a map into a list. So we're giving our map of UTXO, and then we're converting that into a list of key value pairs. Of course, each key value being the the unspent transaction output. And from there, we call the head function, which would get the first element inside a list. And we're saving that value inside our UTXO. Now, if you're curious, we could do some more print statement. Oh yes, we also probably need to import the map module. Okay, the error is on line 69. Okay, so there's a problem with our printing. I suspect it probably is because we need to wrap everything inside params or $sign. All right, there we go. Now let's go simulate. And just for fun, let's create another wallet. So we're going to publish with wallet 1. We're going to wait, publish with wallet 2, wait, and then redeem with wallet 3. Now we'll see that there will be, we'll have a list of 2 UTXOs. All right. As you see, we still haven't redeemed anything yet. But if we scroll all the way back down to our contract, and our log statements only gets printed when we're trying to redeem. So we just look for log, go to the bottom. Okay, so the first one we see over here, this is our map. And you can see that we have our list, and we can see that there is now 2 datums, which is easier to see, but just take my word. But yeah, right here, from this comma, you can see that we have a first UTXO here, and then we have another TXO ref right here, which creates our second UTXO. Now this is using our FromList module, which is basically saying this is a map. In our second function, we call it the toList of our UTXO, which, as you see right here, essentially just has the same thing, but we convert it to an actual list. And then in our final logging statement, which you can see right here, we only have the UTXO for, we only have one of our UTXOs because we just grabbed out the first element. And if we just take this transaction out ref ID, you can see that it is the first list. It is the first UTXO on our list, which makes sense because we use the head function to grab the first element. So great, that's how you get our UTXO. Now we go back to our code. We remove the comments. Now back into our transaction that we're trying to create. We're not actually giving the UTXO. We actually need to give out the transaction out ref. And where do we see this transaction out ref before? If we go back to our UTXO map, the first element in our UTXO ref is our transaction out ref. Specifically, we just need to pass in the first key of our UTXO that we just have. So let's go back to our code. And the quickest way of doing that is currently our UTXO is just a key value pair. And so to access the transaction out ref, which is the first element in our UTXO, we just call in a helper function called first. This will extract out the transaction out ref from our UTXO, and that will pass it into our must spend script output. And of course, as a second parameter, we also pass in the redeemer. And that's all we need to do for our transaction. Next, we need to define our constraint. So our constraint is essentially just a list of conditions that we must create. And I learned this all from looking at the Plutus Pioneer program. So it's not like I somehow magically knew. I actually had to look it up. In this instance, there'll be 2 things we need to include in our constraint. We need to include our contract validator script, and we need to include the UTXO that we want to submit. So both are unfortunately slightly involved, but not a big deal. The first thing we need to do is we need to create our contract validator. So unfortunately, this function, contract validator, is not defined in the starter template, so we have to create it ourselves. So we just go up here and create a function contract validator. This returns a validator object. And to create one, we simply take advantage of some provided built-in functions. And then we just give it our starter instance. And this will create the validator for us. So that's our first constraint. We specify the validator that I'm including, and the next thing, and then we need to add another element to our list. And to add a next element to our list, we need to first concatenate our constraints together. So just from the existing Haskell library from Prelude, I should call it Prelude instead of Haskell, but too late now. I'm just using their list join function, which is just this symbol right here, to combine all of our constraints. So the next constraint we need to create is the actual constraint to spend our UTXO. So we're using unspent outputs. The interesting thing about this is that it actually requires the map object again. And unfortunately for me, what was annoying was that I could not actually get the first key value pair directly from the map. So what I had to do was I had to take the existing UTXO, and what I had to do, and with a lot of trial and error, is take the existing UTXO that I had, that I took the first element, using the key and value that's associated with it, recreate a map with that element, and then pass that map back in. Now, life would have been a lot easier if I could have just figured out how to extract the first element from our map, but I couldn't, so this is what we have to work with. And through trial and error, this is what I got. So using our from list function again, we are reconverting using our from list function from the Haskell map module, we would pass in a list, and then that list would and then from there the function would convert it into a map. And in our case, we're creating a list of one element. Oops, don't need this. Okay, so there we go. In our case, our list contains one key value pair of the key being the first value of our UTXO, and the value or second element is the second value of our UTXO. So in a weird roundabout way, we are just reconstructing the object with the first UTXO that we constructed. So now that we have our remake version of our UTXO, we can just pass it into our unspent output function. And that should be all. Now, you might have a question, how did I know I had to create this remake UTXO? And I can tell you, it was a lot of trial and error. My first initial thought was if I just passed in first UTXO again, the variable would be what the unspent output was looking for. Unfortunately, that was not the case, and through trial and error, I had to reconstruct the exact object type it was looking for, and then pass it in, and this is the end result. So now that we have this, let's compile. Yes, I forgot. We need to include the validator. We need to use the validator from our ledger module. So I believe if we actually just go here and just import the validator. Okay, next mistake. The built-in data, I spelled it wrong. It's built in, not built in. Try again. Okay, so in the transaction, it's not a first. We're not getting the first element of our UTXO, which wouldn't work, which actually doesn't even exist. We need to rename this, and of course, we need to import our redeemer into our ledger API. Another thing you could do instead of importing all these, we can get rid of the explicit classes that we're importing, like so, and just import everything. But we'll give this a try, and we'll see what happens first. Well, I guess I'll just import everything. All right, so I'm not sure what was missing, but we just imported everything and the problem went away. So we'll just call that good. Now we go back to our simulate and we'll do the same thing. We'll publish, wait, redeem, and then wait. Now if you look at our transaction, you'll see that now, while 1, while 2, they still locked up their item, but while 3 was able to redeem only one of the locked up item. And so someone else can come in and redeem the other one, and so on and so forth. So this is kind of what it might take to build a swap. I know this video probably just breezed through and made it look simple, but I promise you, I spent a heck of a lot of time looking at this, probably more than I should have before asking for help. But unfortunately, that is currently the state of where we are right now. Lots of outdated documentation and kind of confusing framework. Hopefully, as time progresses, we'll get better documentation and more support. But until then, it is what it is. Hopefully, you have some insight in seeing how I did some console debugging and looked up the definition of the modules that you see. So it's getting late. I don't want to drag this on too long. So happy development, and I'll catch you in the next video.